In our first lesson in topic 4, we're going to focus on understanding what congruence means for congruent figures, congruent shapes, congruent polygons, etc. And so we're going to try our best to tie this into the unit that we just completed with rigid motions, and that is kind of the foundation for us understanding a lot of these relationships. Obviously, we still need to understand contents from Units 1 and Unit 2, just to make sure that we understand what congruent means when we're talking about segments and angles, that we know how to utilize the correct notation for saying that segments are congruent, for saying that angles are congruent. There's also some key theorems and postulates from previous units that we will utilize in this chapter, or in this unit. And so keep that in mind as we proceed through this material. And if you ever have questions about certain theorems or postulates from previous units, understand that that's a valid question that you can ask. All right, you can always ask us questions. You can always refer to previous videos, and you can also look at previous assignments that you've completed. All right, so our goal is to understand that congruence is simply a reflection of or a composition of rigid motions. Once we understand that, we can get through all the mechanics of how we prove triangles or other polygons congruent to each other. So talking first through some of the verbiage here, figures that have the same size and shape are congruent. We will refer to triangles as congruent, where up to this point we've only talked about these segments are congruent or these angles are congruent. But now we're going to have congruent figures, all right, congruent polygons. If a pair of figures are congruent, that means that there is a rigid motion or a composition of rigid motions that will move one onto the other, showing that all of the angles are congruent, all of the corresponding sides are congruent. This is called a congruence transformation. We will not spend a ton of time with that, but sometimes it's helpful for you to visualize that there is a rigid motion, there is a congruence transformation that maps one figure onto the other. When we have congruent figures, it means that all of the corresponding sides and all of the corresponding angles are congruent to each other. Likewise, remember from Unit 1, Part 2, we discussed how a good definition is reversible, right? And so if we have a situation where all of the corresponding parts are congruent, then that means that those figures are congruent. So we will think about this forwards and backwards. If we have congruent figures, we know that this is true. If we know that this is true, then we have congruent figures, all right? So consider that both forwards and backwards. So congruent figures have the exact same size and shape, and they are correlated to each other with these rigid motions that we've already understood from our previous conversations, all right? And the moment that you can look at a pair of figures and recognize how they are relating to one another, the quicker it will be for you to write your geometric proof, all right? We're going to do a couple proofs today. It'll be very, hopefully very basic. They will be a little bit lengthy, but they will be, hopefully, again, pretty basic. But we're going to understand translations, reflections, rotations, glide reflections, etc., as we try to visualize how these figures are related to one another. So here is a situation where we're trying to understand what congruence means. Here I have triangle ABC. Here we have triangle DEF. And we can notice that this is simply a reflection, that triangle ABC is reflected over line M, and it maps perfectly to triangle DEF. Because this can be written as a reflection statement, these triangles are congruent to each other. This is called the congruence statement, all right? This is our reflection rule or our congruence transformation. This is our congruence statement. It tells us which parts go with which parts. Just like we did earlier in our last unit, that happens here as well. So this tells us that the angle at A corresponds to and is therefore congruent to the angle at D. That angle B and E correspond to each other, and therefore they're congruent. That's that double marking. Angles at C and F correspond to each other. Those points correspond, so those angles correspond. And those angles, therefore, are congruent. These are marked with 3 markings. All right, likewise, segment AB corresponds to segment DE. So AB and DE have the single mark, the double mark, the triple mark, etc., etc. So because this rigid motion exists, it means that these triangles are congruent. And if the figures are congruent, it means that all of their corresponding parts are congruent. All right? So we can list each of these statements discussing the fact that each of the corresponding sides, each of the corresponding pairs of sides are congruent, each of the corresponding pairs of angles are congruent to each other. Make sure you have all this information down because I'm going to have you do the same thing on the next slide. All right? So what I want for you to visualize here in this next picture, and pause the video, go back if you need to copy that stuff down. But here we have two triangles. Are the triangles, I'm coughing, are the triangles congruent, yes or no? Well, what I want you to do here is I want you to answer yes to that. I want you to understand that this is merely a reflection, and therefore these figures are congruent. I want you to write their congruence statement right here, and then I want you to list all 6 pairs of corresponding congruent parts, all right? The 6 pairs of corresponding sides and the 6 pairs of corresponding congruent angles, all right? So do that, pause the video if needed. All right, so again, mapping a figure onto a congruent figure, mapping a figure onto its buddy there, is going to involve some comprehension of those rigid motions, all right, that we've just spent the last 3 weeks talking about. So here I'm giving you this statement. I'm telling you that these figures are congruent. And what you do in your mind is a couple things. One, you try to understand how these parts are related to one another, even without the pictures. I'll have you do that next. But here with the picture, we should be able to visualize that J needs to map to M, K maps to N, and L maps to P. There's almost like a rotation that would bring us here, maybe a rotation and a translation, that would move this triangle such that J lines up with M, K moves over to N, and L lines up with P. All right? If that's the case, then let's list all of those corresponding parts. All right? Pretty redundant from the last 2 slides. But we're going to show here that angle J goes with and is therefore congruent to the angle at M. That angle K corresponds to and is therefore congruent to the angle at N. That angle L is congruent to the angle at P. Whoops. There we go. That's P. Furthermore, we know that not only do these angles correspond to each other, but the segments that join those angles are also congruent to each other. So JK is congruent to MN. Now, if you wrote that backwards and you said NM, that is not untrue, all right? However, it is not helpful to write this backwards. And the reason is we know that J corresponds to M. So you will do yourself a tremendous favor this unit, even though NM and MN are the same thing by the reflexive property of congruence, that we ought to write this in such a manner that it details which points correspond to which points. That will serve you so well if you commit to doing that for this unit. Again, if you wrote it differently, it would not be wrong. All right. However, it may be not helpful. You want to work through these items in a very helpful way. Now also, this can be a little bit confusing to look at this picture. Does KL go with this side or does KL go with that side? That is a very difficult concept at times if you are not understanding how this figure maps onto that one. And I purposefully put a pair of isosceles looking triangles here, even though we don't know if they're isosceles. All right, but what I do know is that based on this statement, KL goes with NP. All right? And you can look at this the way that it's mapped out. We have the single, then the double, and then the next side. All right? The single, the double, and then the non-included side there. So I know that this should be NP. And then that leaves the last segment that goes from L back to J, being congruent with P back to M. All right? So we should be able to look at a congruence statement and or the picture of congruent polygons and list out all of the 6 pairs of corresponding parts. If there's triangles, it'll be 6. 3 pairs of angles, 3 pairs of sides. If it's a quadrilateral pair, then there will be 4 pairs of angles and 4 pairs of sides, etc., etc., etc. Okay? Most of our examples will deal with triangles this unit. Hopefully that's good. We can also do this same task even without a picture. All right? So part 2 here, I want for you to try, I know it doesn't say you do it in the corner here, but I want for you to try to do this without the picture. Can you tell which letters go with which letters, and therefore which angles are corresponding and therefore congruent to which angles? Which sides are corresponding to which sides? Can you make those connections? See if you can list those out. I will give you those answers when we are back in class. All right, and now we get to do some proof. Now, proving triangles congruent, pause the video if you need to go back to that last example. Proving triangles congruent means, at this point, with all the information that we have, we need to show that all three pairs of corresponding angles are congruent and all three pairs of corresponding sides are congruent. Understanding which sides correspond to which sides and which angles correspond to which angles is the work that we've just done for the past few weeks. Here, we should understand that if I were to flip this piece over, if I were to rotate that 180 degrees about point C, that I would line up these right angles with each other, these sides with each other, these angles with each other, and these sides with each other. So I can rotate just this part, and you would see that this would map over that perfectly. So we want to show that ABC is congruent to and corresponds to EDC. So we're going to prove this, but we're going to do this in a very meticulous, almost painstaking, step-by-step manner. This is going to be a long proof because of the information that we're given here. Notice that we are given lengths of sides. We are given right angle pair, a congruent angle pair. We're not given something here. We are given congruent sides there. So there's a lot of thinking for us to do here. So what I'm going to do first is I'm going to address the situation with the sides. If I can show that all of the sides are congruent first, then I will go to talk about the angles, all right? So watch this process. This is a lengthy process. I'm sorry for the length of the video here. You can play this on 2 times if you would like. But basically, I'm going to say that the length of segment AB is equal to the length of segment ED, and I'm going to say the length of segment BC is equal to the length of segment DC. This information is given to us in the picture. All right, these are both equal to 3, so they're equal to each other. These are both equal to 4, so they're equal to each other. That means that these segments are congruent. Whoops. And it means that these segments are congruent by the definition of congruent. Remember, congruent segments have equal lengths. All right, so if segments have equal lengths, then they are congruent. If segments are congruent, then they have equal lengths. So we're going to use the definition of congruent segments. You can write congruent segments here, or you can just write definition of congruent, and that will work for us. Also, we know that segment CA is congruent to segment CE. That information is given to us in the picture. It's marked, right? So I know that that's true. We have now shown that 1, 2, 3 pairs of sides are congruent. Also, notice the order. I wrote AB and then ED, AB and then ED, BC and then DC, BC and then DC, C back to A, C back to E, just like our statement reads. Also, I know that angle A is congruent to angle E because they told us. I know that angle B and angle D are right angles. Whoops. Because they told us. Ooh, actually, Mr. Hibbett, you botched that. Womp, womp, womp. I know that segment AB is perpendicular to segment BC, and I know that segment ED is perpendicular to segment DC. Come on, Hibbett. Do a better job there. Do a better job. We're going to state that this symbol again means perpendicular, all right? I know that those are right angles, but what we talked about last unit or 2 units ago was this particular fact. This means that the angle at B and the angle at D are right angles by the definition of perpendicular. Perpendicular segments make right angles, and that means that angle B and angle D are congruent because all right angles are congruent. That was a theorem from Unit 1, Part 2. All right? So I've got 2 pairs of angles. I need that third pair. I need these angles around C to be congruent to each other. Luckily for us, these are what are called vertical angles. Vertical angles. And so we know that the angles are congruent by the vertical angles theorem. And I'm going to call this angle BCA congruent to angle DCE by the vertical angles theorem. Now I've shown that all three pairs of angles are congruent, all three pairs of sides are congruent. Therefore, the triangles are congruent. I can copy that. Triangle ABC, congruent to triangle EDC by the definition of congruent triangles. All right? So what this shows us is that we can work very meticulously, step by step, to show that these things are congruent. As we work through this chapter, much of this will get a lot shorter and a lot easier for us to do. However, there will still be some more challenging type proofs. This one is not intended to be challenging. It is intended to challenge you to think about how we write our proofs. And then we'll continue working from there. All right? If you have any questions on this, mark that in your notes and we can discuss it in class. All right. Can we prove that these two triangles, ABC and EDC, are congruent to each other? If so, write the proof, and if not, tell me why, and then we'll do that. Hope that the algorithm doesn't flag this video for copyrighted material. Okay, here we go. All right, the last thing. We have a corollary to our triangle angle sum theorem. Basically, if you have two angles in one triangle that are congruent to two angles in another triangle, then because of the restrictions of the triangle angle sum theorem, these two plus that third angle have to add up to 180. So if we have two angles in this triangle congruent to two angles in that triangle, then the third pair of angles has to be congruent. All right? The third pair of angles have to be congruent. If these angles are congruent, these angles are congruent, then this third pair has to be congruent. All right? We can work through a proof of that if you would like to, but if we do x plus y plus z equals 180, and this is x, and this is y and y, then this has to be z and z. There's not really a very exciting algebraic proof to do there, but I can do that for you if you'd like. Just come see me during seminar. So if two angles in one triangle are congruent to two angles in another, then the third pair of angles will be a congruent pair. We will use that to prove that these two triangles are congruent to one another. Draw that picture to the best of your ability. And by the way, if you haven't been putting pictures in your notes, you need to put those, so go back in the video and copy those pictures down as best you can. But you'll see that we're given a lot of information. So while you're copying that down, please pay attention here. The angles around point P are congruent. The angles around point R are congruent. These segments are congruent, and these segments are congruent. But we are not told that the third pair of angles are congruent. We're going to use that corollary. And we're not told that this side is congruent to, that this segment is congruent to itself, that third side for each triangle. But it's the reflexive property says that this segment will be congruent. So what we're going to do is we're going to show that all 6 corresponding parts are congruent to each other. We'll start with the segments. PQ and PS are given congruent. It's marked in the picture. QR and SR are given congruent. We could write that as one step if we wanted. Also, we know that RP is congruent to RP because of the reflexive property of congruence. So I'm going to put that in here because that is something that we deduced, that we thought through. This is given, this is understood. All right? Next, the angles at P. Notice how I named these angles. The angles at P, we have QPR, reading it this way, QPR and SPR. So I'm talking about this angle here. We want to make sure that we can name those angles using 3 letters. I can't say angle P is congruent to angle P because we don't know which angle P you're referring to. There's 3 angle P's in this picture. But angle QPR, there's only one of those. Angle SPR, there's only one of those in this picture. We also know that the angles down here, PRQ and PRS, are congruent. That is also given. And finally, if we know that 2 pairs of angles are congruent, then we know that the third pair is also congruent. So angle Q is congruent to angle S. I can use one letter for these angles, reviewing back to the very first unit, because if I say angle Q, there's no confusion what I'm talking about. But if I say angle P, am I talking about this angle or that angle? So we need to make sure that we are using correct notation as best we can. All 3 pairs of sides congruent, all 3 pairs of angles congruent, therefore our triangles are congruent by definition. All right, and we rewrite our statement. One thing that you should notice is that I try to keep these pieces on this side of the congruent side and these pieces on that side of the congruent side. It is, again, not required, but it's extremely helpful to organize your thinking so that you can be successful in this unit. If you follow my advice and you organize your work in that way, it will go well for you. Additionally, Notice how these reasons are all tabbed together. So when you are writing your statements, give yourself some room so that all of your reasons line up. It'll make it easier for you to check if you're doing things right or if you have corrections to make. Folks, that is the end of this lesson. I hope now you are able to use compositions of rigid motions to show that two objects are congruent. All right, that you understand the parts and pieces of triangle congruence and that you are excited about moving forward. Have a great day.